The front nose of the RB20 is quite different to the RB19 in its approach. It loses the RB19's blunt nose tip that works with being detached from the front wing mainplane. Instead, Red Bull Racing's approach on the RB20 is to run a sharper, more aerodynamic front nose, but this time it is attached to the front wing mainplane. Design of the blunt nose is to create wake that would wedge and force air between the nose tip and front wing mainplane. This would create high velocity on the undernose, while the shape under the nose and mainplane could work together to further guide airflow upwards instead of being more sensitive to flow separation. This means that they can apply more angular undernose designs. From the onset, it seems like the RB20 sharper front nose design is done to clean the airflow underneath and generally around the front nose region. With their previous design on the RB19, maybe they were trying to get the front nose tip region to contribute to some downforce in order to reduce front wing aspect ratio airflow for a given amount of total front downforce. The split mainplane together with a more rounded nose tip, however, would not gain smoother airflow towards the tunnel entrances and instead encourage airflow to stay attached and conform with the shape of the undernose. In this image, it makes for a case for this that the Flovis markings show more airflow from the undernose being redirected to the top of the floor entry on the RB20 compared to the RB19. It also shows how much wake is generated by the ground effect floor that it may not work as a complete Venturi's thought. Considering how much work is done to extract airflow from the rear of the tunnels, this should not be happening. It can clearly be seen that a lot of air is flowing into the undercut and also where the vertical intake is positioned. Improved airflow approaching this region would further enhance underfloor and top floor aerodynamic performance.